Hello and welcome to Cathode Rays. This piece of equipment here is called a discharge tube. And an understanding of the way that this piece of equipment worked led to the discovery of the electron. Now we know an electron is a negatively charged particle. It is not a wave or a ray. But at the time when this piece of equipment was being analysed, it was not known. We didn't know whether it was waves, rays, or particles that were interacting with the gas inside this tube. So what we have is a negative cathode and a positive anode. And these are connected to a high voltage power supply. Inside the tube you have a low pressure gas. You need it to be low pressure because that allows the particles of gas, the ions and the electrons, to build up a good big high velocity, and that causes this glowing effect. So what happens is that when the circuit is connected to this high voltage, the gas inside the tube ionizes. It splits into positive ions and negative electrons. The atoms have their electrons stripped from them. And what happens is that the positive ions travel towards the negative cathode and the negative electrons travel towards the positive anode. And they collide inside the tube. And they do so with such a high energy that we get light being given off. Now you'll be familiar with emission spectra. And it's this effect. This is what's going on inside the tube. Now we know that the different elements inside the tubes produce different types of light, and that's to do with the arrangement of the electron shells in those elements. And we do get different colours inside the discharge tubes. But it's all down to the same effect, the movement of electrons and them recombining into the atom. Some of the first discharge tubes were developed by Julius Plucker, a German physicist, in 1859. He was the one that first observed this effect. He also noticed that if you put a magnet near the tube, then you can move the light around. It responds to a magnetic field, which indicates that the particles or the waves inside the tube have a charge. Later, in 1876, another German physicist called Eugene Goldstein experimented with the shape of the cathode to try to see how the cathode rays are being given out. He experimented with a point and a flat surface. Now we know that when you have a point light source, the light is given off in waves in all directions. And if it's a flat surface and it's light, you would expect it to be given off in all directions. But what he noticed was that when you have a flat shape for the cathode rays are given off at a perpendicular angle at 90 degrees, which indicates that it's likely to be particles. In the 1870s, an English physicist called William Crookes was able to improve and lower the pressure of the gas inside. He put a piece of equipment inside that could rotate like a paddle wheel, and when the cathode rays struck it, it rotated. This indicated that they were particles with mass because they had momentum. Another physicist in 1883, a German physicist called Heinrich Hertz, who wasn't very well known at the time but is now quite famous, his experiment showed that there was no charge at all on cathode rays, but later this was shown to be experimental error. In 1890, Arthur Schuster was the first person to calculate the charge-to-mass ratio of cathode rays. But because the number that he came up with was approximately 1,000 times bigger than anybody expected it to be, his calculations were largely ignored, but later turned out to be correct. In 1896, Henri Becquerel calculated the charge-to-mass ratio for beta particles, and that number was found to be very similar to the number that Arthur Schuster got. Now we know that a beta particle is just an electron. It was J.J. Thomson that did lots and lots of different experiments and brought together all of these disparate ideas. He calculated the charge-to-mass ratio of the beta particles. He did it for lots and lots of different gases. He calculated the charge-to-mass ratio of cathode rays given off by thermionic emission. And he brought together all of these values and discovered that they were the same, because it's all the same particle doing all of these things. And he was the one that brought all those ideas together and is recognized as being the person who discovered the electron. Later on, in 1909, Millikan and his associates did some much more careful calculations about the charge-to-mass ratio, and we'll talk about those later.